All right, let's talk a little bit about what are called the conic sections, different shapes, different types of curves. The first one we've dealt with before, and I have an example here. It's y equals x squared minus 1. That is actually called a conic section also, but we did talk about it without calling it a conic section. But this shape actually is the parabola, right? Shape is one of the conic sections, and y equals x squared minus 1. That's just the x squared graph, one shifted down. So we've talked about that a little bit. We'll talk about it a little bit more because if you'll notice, we have also another parabola on number 2. X equals 1/4 y squared is the one I have just below it there, but you see there, that's also a parabola. But what's the difference there? I usually call it sideways. A sideways parabola as opposed to a vertical parabola that we've been doing. So what is different about this equation and graph? We just said the graph-wise, well, it's sideways instead of vertical like we normally see parabolas. What's different about the equation? So looking back at the two equations, the other one was y equals x squared minus 1. What's different about number 2 equation compared to number 1 equation? The ones we were graphing look more like this. This one, the sideways one, looks like that. What's different? The y squared instead of the x. Yeah, the x and the y have kind of switched around. We've got y squared instead of x squared. And x is to the first, the y is to the first on number 1. So when you do that, that's what happens. The parabola turns sideways when you have the y squared instead of the x. Okay? And then one thing I would point out, I'm just graphing these by table right now. This is not how I actually will do these. Well, actually this one we will rely upon a table, but a lot of these we won't use use a table a whole lot. On these, though, we will. I should clarify that. But anyway, you can see the difference here and why we get a sideways parabola. And then notice here, too, that the difference here when I'm graphing this one, when I do x is 1, for example, I've got two y values, plus and minus 2 y values that go with that one x value. So you've got a plus 2y and a minus 2y. And so anyway, that's why you kind of get the sideways thing going. And then when you plug in x to be negatives, well, that's not going to work out too well because you have a y squared to get x as negative, and that's not going to happen too much. So on the real number side anyway. Okay, but we'll say more about that in a second. So what's different about the equation? Well, the y is squared, not the x. If you want to write something down there. Okay. All right, so go to the second page there on the handout, and we have x squared plus y squared equals 25. And so this one, like I said, I just did these by doing a table, and I've got the table there to save time. This is, like I said, not actually how we'll do most of these with the table, but just to kind of get us going to recognize some of the so another conic section is this shape, which is a nice little circle, right? So if I graph, put the points in for x squared plus y squared equals 25, we'll note there, yeah, this is a circle, and a lot of times we'll be keying in on the center. Well, the center of this circle is at 0, 0. And then we also might notice that the radius is 5. The radius is just the distance from the center to the outside of the circle. Well, that's going to be 5 any way you look at it. So this is a circle. So my little question is, what's different about this equation and graph? Well, we've already mentioned that it's a circle instead of a parabola. And why are we getting a circle instead of a parabola here? Well, both the x and the y are square, yeah. we've got the x and the y being squared. On the parabola, you just have one or the other is squared, but on a circle, you've got x squared plus y squared, so you got, yeah, both of those are squared. There's a little more to it, as we'll see in a second, but that for now, that's what we might want to note there. Okay, so that's the basic equation of a circle, what it looks like. Okay? Now, on number 4, notice, I do have x and y squared, but it's a little bit different. But this is the way we'll start these anyway. This shape is called, and so if we graph the points and so forth and so on, here's what we get. And this shape is, anybody know? Egg? Looks like an egg shape. It's technically called an ellipse. This is the ellipse shape, and of course it's very much related to a circle. Actually, a circle is a specialized ellipse, but yeah, we get this kind of egg shape. It's called the ellipse. So this is what the ellipse, what's the difference here in this equation? Well, this is the way we're going to want ellipses equations to look like. Notice the x and the y are squared, but I've got a little different format here than the circle because notice I've got these denominators, and we'll talk more about what all this means. I've got these denominators, and then significantly here also, it's equal to 1. This equation is set up, so if you've got an equation that looks like this, that is going to be an ellipse. Okay? And then the last and final shape on the back side here, I've got 2 of them. A really strange, the 4th, if you will, conic section is this shape, which is a lot different than the other 2. Well, I guess this more looks like a parabola, but what's different between this and a parabola? We've got the two branches, we call them. You've got 2 branches instead of just a parabola that has, has just the one thing there. So that separates this from being, parabola. And then also, what's different about this equation compared to the other equations? Why do I get a different shape here than, say, it looks a lot like the ellipse equation, but why is it not an ellipse? Yeah, you got this minus here. A minus between these shapes here. Okay. A minus between those 2 x squared and y squared expressions, that's going to give you a hyperbola. So that's the difference between an ellipse and a hyperbola. Now, what's the difference between this and a parabola equation-wise? Well, it's because you got the x and the y are squared. So again, you got x squared and y squared, but it's a minus between the x squared and y squared terms. Okay? So yeah, when you have that, you get these 2 branches, and we'll say a lot more about this and how it actually graphs. And notice in the middle here, I get some of these not real values again. It has, again, to do with the equation. But anyway, that's the points I came up with. But again, notice you've got the 2, you got the x and the y, 2 y values for x values there. But anyway, this is not how we'll actually graph this one. But you can see how the points work if you look at it a little bit. So this is called the hyperbola. And hyperbola is this shape. Basics of it. One other quick note there are some asymptotes involved. You remember we talked about asymptotes a little bit. There's an asymptote, they kind of go diagonally. I'll tell you how we can get these later on, but for now, just note there are these asymptotes, which are lines that the graph approaches. They're diagonal asymptotes. They're lines that the graph approaches without ever touching. They get closer and closer to these asymptotes, but you might note there is an x set of asymptotes there. All right, we've already talked about the differences. The minus between the x squared and the y squared term. Okay? Now, one other note, just so you know, there's another type of hyperbola. This is a hyperbola also. It's got the two branches. What's different, though, about this one? Well, the branches are up and down. I call them, you've got upper and lower branches. This is an upper and lower branched hyperbola. Whereas this one has right and left branches. The top one. So you can have that variety as well. You can have right and left branch ones, and you can have upper and lower branches, hyperbolas. Now, again, you see you've got the minus between it. Now, why do you think it might be a difference between the upper and lower and right and left? Yes. It's the one that's first or second or however you want to put it. Yeah. In this one, we've got the y squared minus x squared. Whereas in the one on number 5 there, I've got the x squared minus the y squared. And that makes a big difference. It's the difference between right and left and upper and lower. Okay? And we'll say more about that. But for now, that is what I wanted to show you on this. Those are our differences in all the types of conic sections. So let's